Hello guys, welcome to Inspire Educare. I am Aditya. In this video, we will solve one problem from the topic linked list, which is generally asked in interview. Today's question is to find the middle of a given linked list. So in this, we are given a single linked list. We have to find the middle of the linked list. So if there are even number of nodes, then there will be two middle nodes. So we need to print the first middle node. Let's understand with the help of an example. So the first example is of a linked list having odd number of nodes. So we have an input 1, 2, 3, 4, 5. So the middle one is this 3. So the output comes out as 3. The other example is of a even number of nodes. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the middle element are these two. So we have to return the first middle element if the linked list consists even number of nodes. So we will return 4 as an output. So to solve this question, we can traverse the linked list and count the number of nodes. Then we can again traverse the linked list till count by 2 times. So in this we have to traverse the linked list twice. So let's see another approach in which we have to traverse only single time. So let's see an example. So here is a linked list 1, 2, 3, 4, 5 and 6. So in this approach we will use two pointers. The first one is slow pointer and the second one is fast pointer, which will point both will point to the head of the linked list. So in this approach, we will move fast pointer by 2 steps and slow pointer by 1 step. So when fast pointer reaches the end of the linked list, the slow pointer will point toward the mid element. So let's see. When we first update our fast, so the fast will point here, then slow will point here. Now when we will again update to fast by 2 steps, so it will point here. Now this will point here. So if we again update, then it will point at the end. So this is the element which we will get as a mid. So let's see the condition at which we have to start, which we have to stop our fast pointer. So for even node, when fast reaches this point, that is one element behind the last element, so we have to stop because the slow pointer will point toward the middle element. So here condition should be when fast next is equal to null. So then we have to stop when we have a even number of nodes. So let's see for odd number of nodes. So here is an example 4, 5. The slow will point here, fast will point here. So we have to increase fast by 2 and slow by 1. So after increasing, fast will point toward this, slow will point toward this. Now again after increasing this, so fast will point toward this and slow will point toward this. So this is the condition where we have to stop when it have a odd number of nodes. So here the condition is fast next equal to null. So these are the two conditions when we have to stop to get the middle element. So let's see the code for this approach. So in the program, we have a class node, and we have a public data member, data and node start next. And we have a constructor node entity to initialize data and next. So let's see the main function. So in main function, we have first created a node head and initialized it with null. Then we have called a build list method and passing one argument head in it to make the linked list. So let's see the build list method. So in build list method, we enter the data first, and when data is not equal to -1, we insert it in linked list. So -1 is considered as null in this program. So when we have enter -1, it will stop taking input, and in this we have call a function insert at tail, and we have passed two argument head and data. So in insert and tail, if the head is equal to null, then we will create a new node and make this node as head, and we will return. Otherwise, we will create a node variable temp, and we will iterate the linked list to find the last element. Then we will connect the last element to the newly created node. So let's see the other part of the code. Then we have printed the list. This is the simple one. To print list, we have to traverse the list simply. Then to find the middle element, we have called function middle ll, and which we have passed head as an argument. So coming to the middle ll function, it has a return type of int. So when head is equal to null and head ka next is equal to null, so we will simply return the data of the head. Now we have created two pointers, slow and fast, and initialize it with head point. So we will now run a loop till this condition become false. So when fast is next is not equal to null and fast ka next is not equal to null, we will run the loop and update our slow pointer as slow equal to slow next, and update our fast pointer as fast equal to fast next. So we will update fast pointer by 2 and slow pointer by 1. So after coming out of the loop, the slow pointer will point toward the mid element. So we will return slow data. That is the data part of the slow node. So let's see if it is working fine. So we have to enter the element of linked list. Let it be 1, 2, 3, 4, 5, 6, 7. This is odd number of node in this linked list. So we will get a output as 4 because this is the middle element. Let's see for even number of node. So here is 1, 2, 3, 4, 5, 6, 7, 8 and -1. So in this the output comes out as 4. Since we have two middle elements 4 and 5, we have to return the first one. So the output comes out as 4. So that's all for this lecture. Thanks for watching. I will see you in next lecture. Till then, keep learning and keep exploring.